Hi, welcome to yet another Azure Corner meetup. I prepared a little nice presentation. I'm still trying to find it. We were speaking here and we had too much fun, so let's see if I can find it eventually. But today we're going to talk about caching in the cloud. And you told me it's more on a general level and not Azure specific one, but all the technologies can be applied, private cloud, Azure cloud, any other working cloud. I'm not going to mention them. Caching in the cloud, yes. And I would really like to bring up my presentation here. So if everyone, just gives me a minute, hopefully it will be worthwhile. I have some goodies, I have some announcements and other stuff. But another tip, productivity tip, you could restart your computer from time to time. Because when you open it, it takes some time. There we go. So, but of course, the page doesn't open. Let's do it differently then. Maybe we could come back to the presentation afterwards. So we will run your session first, yeah? But just a question, who's first joiner here? Nice. And all the others have been here before. Happy that everyone came back. So we're gonna let you start then. Okay. And then I'll fix this connection here. Yep. And yeah.
Should we have a short word from our sponsor before?
That would be it. So now you come up. You could have told me before. Yeah.
Hello, my name is Anders Högberg and I am from Capiche. Oh, look here. Hello, my name is Anders Högberg and I'm from Capiche, as you can see there. We're a software company who is just on the other side of the road from here. We make software for analyzing clinical and scientific data. And we are the ones that bring in pizza here. And we like Azure because it's our backend. And over to you, Gregor.
Okay, thank you. I already got one.
Yeah.
Microphone, so let's put it here. Okay, can you hear me? Okay, good. Caching in the cloud. My name is Klockare. I'm from IT-huset, and here's a picture of me using AI. Keywords used is Gregor, cloud, architect, firefighter, reference to Nile City, if you remember. Not sure. Dystopia, things like that. And again, Gregor Klockare, representing IT-huset. We're about 100 or so consultants. We're representing Stockholm, Lund, and Uppsala. I have about 30 years in this industry as a consultant, mainly architect, developer, then architect. I'm responsible for we have a program, architecture program, system architect, and of that branch in our company as well. So, does it look like me? Well, there's a cloud anyway. So let's zoom in to the problem. Why do we need to cache? Why do we want to cache in the first place? The response times are not acceptable, way too slow. The usability of the system is hurting. Or even we can't meet our requirements, like simultaneous users, or we got intensive transaction handling. So what to do? Redesign the system or something else? So what is cache? So that's why you're here. What is caching? The word cache stems from French. French word cacher. The pronunciation, I think it's right. I'm not sure. I tried. Means hiding, hide. So cache is a component that stores copies of data in order to future requests for that data to become much faster, to be served faster. We see it everywhere, all the time, in almost every solution, like Netflix, trending now, Netflix originals. I follow their tech blogs and how they use it, and so on, for example. We can agree to that. So the reason is, so again, as an architect, we always start with the question why when we design systems. At least I do. Why do we suggest a certain design or solution? In any case, we have already answered that. We need to speed things up. Many see it as an anti-pattern not to cache. Some see the other, the quite opposite. The anti-pattern is to cache. Come back to that later. Question. Now we know why, but where do we cache? Any suggestions? Yeah. Pardon me?
In memory.
Yeah, in memory cache. Redis, exactly. That was what I was expecting. I was expecting the answer Redis. Yeah, that's one way of caching, which is very good at that level. But specifically in our cloud environments, our internet-based systems, you can cache almost everywhere. And I think you will utilize that. All those cloud services, what are they? What can they help them? Which caching can we do on those different services? So here's a short one. At the desktop, the client mobile units can cache, browser cache, we get local cache, DNS cache, DNS cache cloud. What's that? I come to back. CDNs, edge cache. We got the response cache, sometimes called HTTP cache, API cache, whatever. Dear child has many names. Then we come to this one, distributed application cache, Redis and memcached. Both of them are quite commonly used. And then we have some caching on the persistent layer as well. ORM caches, you have probably heard of. If you're using relational databases, or some, not caching, but techniques to speed things up on the persistent level. So all those together, combined or just choose some, may be part of your solution. Are you with me on that? So where do we start? We start closest to users. Get the browser cache, DNS cache, and local cache. Well, a quick look at the desktop. We got the usual HTTP cache, more commonly known as the browser cache. You can invalidate it. You can set up TTLs for caching and so on, depending on the browser really, but nothing new here. But as default is used. And so the browser cache is a DNS cache. What's that? Domain name system, servers. Well, you need a human readable domain name. You need to look up the real IP address, of course. And usually use your local ISP's DNS server or the public Google DNS server. So traditionally, this was just the DNS cache that was available if you're using those two, which many of you do. However, cloud DNS, what's that? I think them as DNS plus. They got some add-ons on top of what the Google DNS and so could offer. Here's the Azure DNS, working in conjunction with your local ISP's DNS server. Azure DNS is hosting service for your domains, your virtual networks. can catch up to networks. So faster lookups for your virtual networks in your cloud. They also provide, there are some hacking, so DNS poisoning, cache poisoning, DNS, I don't know. There are some hacker specialties according to DNS cache poisoning. The Azure DNS services claims that they hacker-proof DNSSEC as well, and very fast solutions. And now, not only Azure, all of the cloud vendors have the same. The cloud DNS have even added more functionality. In a multi-regional system, so you got one region, cloud region, using your one network there. Cloud DNS helps redirecting requests depending on which user asking for it. So you can redirect to the closest cloud region. So does everyone. Doesn't matter. This is AWS, but it doesn't matter. Azure, AWS, Google. Not only will the solution be faster, your cloud solution will be faster, you can also localize your system. Let's see, if you're a user in Australia, you can be redirected using the DNS service to that virtual network in that region. So faster, and even the possibility to localize your system in that way, using your cloud DNS. Not the usual DNS, the cloud DNS. Not just redirecting to the nearest cloud region, but also can add failover routing, weighted routing for your networks as well. So that have been I didn't know that before. Does anyone use that of you in your solutions? Failovers, okay, good. So that's one. I would recommend you to look into the cloud DNS. It differs from the ordinary ISPs, your internet service provider DNS and Google DNS, the public one. No, you need to look at what the other possibilities. You can actually cache the names of your virtual networks, go faster, because there is a loop. You need to look up for that one. It takes time. So you need to speed things up. Here's one approach. And not only that, you can have failover and weighted trafficking for your solution, especially if it's multi-regional ones. Back to the client devices again. Sometimes you need to set up local cache in your desktop, mobile unit, whatever. Google's PWA, Progress Web App, states not only that the website should look like and behave like a mobile app, it also states that the user should be offered an offline mode. So if you're using PWA, then as a requirement for your application, you need to offer the user an offline mode. So how do you do that? Here's a local cache implementing using the cache side pattern, also called lazy load. The flow is pretty straightforward. First, the yellow loop, saying look for the data in the cache. If it's the cache miss, go for the green loop. Get the data. When returning, add that data to the cache and so on. It's called the cache aside and lazy load. So if you're using the PWA, or you need to address then you need to address the offline mode as well. Someone has used that, local cache, like on the mobile, in order to offering offline mode. That's probably a requirement today, as of today. Okay, that was the DNS cache and the client caching. So let's go to the internet. Caching on the web, static web content caching, CDN's edge cache. They're out on the edge locations. I'll tell you, about it's called Content Delivery Network. That's the CDN stands for. Got the edge server the first time. Had this loop back to the source, and then it's cached up. It's a static resource cache, like pictures, even web HTML sites, and so on. The name, I heard, doesn't matter if I come to a customer. Some called CDNs, POP servers, edge servers, POP edges, and combination all those words. Same thing. The use of this CDN cache as of today is quite common. Probably the most common caching component in our systems, our internet-based systems. The cache is all about static web content, hence the name. CDN is nothing new, but are heavily used in cloud solutions. And like the DNS, there are some add-ons on top of that as well as CDN. So CDN clouds differs from like earlier versions of on-prem CDNs. First, for all clouds, this is AWS. Doesn't matter. I thought they had a very good picture on the regional edge cache, how that works. Caching is made in several layers. They're using their infrastructure for that. So it's not just the edge location closest to the user. It's even the regional caching as well. Here's the AWS, but again, it doesn't matter. The CDN caching, all cloud vendors support that and offers that. So let's say we got two persons using the same systems. We got the resource in the region, in one cloud region in the US. One is in Helsinki, one is in, I don't know, Rome. Using the same systems, the regional cache in Europe first takes it after the first request. And then we're caching up to the edge locations as well. So let's say we start with the Helsinki guy, the Finnish guy, and next time the guy or the girl from Rome, you will use this static picture or whatever you need to. We have set up caching from the regional cache. So here we have another more advanced cache than previous ones. So next time we are designing your cloud solutions, you can also think of the CDN and the caching probabilities and possibilities to use for static content. And use that in your favor when the caching system speed things up. The configuration is pretty straightforward. Here's the AWS. You just set up your CDN cache policy. Here is a sample. You have some type of pattern, like type of picture format. Could be JPEG, HTML, wildcard. Setting up the source, origin, and the TTL, time to live, for that. In this case, 86,400, like 24 hours, just stated in seconds, I guess. Doesn't stop there. Cloud CDNs now offers you the ability to deploy cloud functions and lambdas at the edges. So you can add functionality. I saw one, and I needed to check one use case for it. I saw someone using some lambdas, and they filtered out all the requests. Because if it's cached, the request stops there. So you need to actually go to the edge and have some logic there. And attached to their kinesis, it's like event, some sort of streaming platform, streaming service, in order to analyze it later. So now you can deploy your own logic at the edge, at your edge or CDN service. And again, it doesn't matter if the previous slide showed AWS, CDN, CloudFront. In this case, it applies to all cloud vendors, and we have caching rules using Microsoft Azure CDN Content Delivery. I think that's a better name. It is what it is. AWS has very strange names. You're setting up the caching rules here at your CDN service. Has someone used it? Great. Have a look at it. Here's a place where you can actually speed things up. But it's static web content, okay? So when you're designing your systems, here's one way of doing it. And using the cache. Okay, so the web content is here. We're moving towards the more core part of our system. We've got the response cache or HTTP cache, API cache, got the distributed application cache, Redis and mem cache usually, and we got the database, persistence layer. So we start with API gateways. That are usually one of our portals to the system. Let's say REST APIs. Again, nothing new. We had, for example, Nginx and NetScaler and those. But as the name implied, that's the serve as gates to our system. So what can be done here? We can cache the responses. This we can do. And meaning by that, first of all, you set up which request. Like here is get. What to cache for how long. Let's put up a get. Get in this case was the HTTP get method and some listings of cats. Also you need a TTL for that, but it doesn't show up in this capture. The pattern of this cache is also pretty straightforward. They're also using the cache side pattern, aka lazy load, with the TTL. Simple request reaches the gateway and requested data doesn't exist in the cache. It's a cache miss. We need to request the data from the source. On the return, we add the response to the cache and return it to the client. And we have a TTL for about like 900 seconds, like 15 minutes. Again, as many of you already know, we're using the cache side pattern. I'm an architect. I like the pattern language, as you may notice. So next time we have a cache hit. It's simple. Look for the cat, get method, look for the cat list, and there we have it in cache. We don't need that loop on the request, the source loop. We need to just return the cache data and reset the TTL, the timer. And that's why we're caching in the first place. And here you can save and speed things up a lot, very much, at the response cache. Usually, if like at microservices, the gateway acts like an aggregator. You probably have several requests, you aggregate and before returning to the client. In the response cache, return the response as it is. It's already aggregated. So if you want to speed things up, this is a place to start using the response caches. Especially if you have many microservices. If you got one, you don't. I mean, here's 4 request loops. You need to, or 5, or 4. You need to aggregate first before sending back the data. Here's an aggregation, cache the response before return it. So once the response is cached, return to the client. Therefore, it's a way to actually try to look to cache to speed things up. Is the response cache. And again, in Azure, we got the API management. There is a new, smaller version service as well, aren't there? Not sure, but this is the main one. However, same thing. Set the cache policies for that. Which HTTP method, with what resource, and here's the thing. What I like in Azure cache store. I heard Redis. You can actually you can put out an external cache store like Redis already here at response cache as well. So use Redis in this way. It's actually pretty straightforward in the configuration as well, which I like. A bit harder on the other cloud vendors. So here's one way of using Redis. Right from the bat in the API, in the response, the API gateway. Okay, we passed our portal. We're moving on to the backend. Ending up on internal parts of the system. And then we got the usual distributed application cache with everything. Redis and memcached, the persistence layer. So we'll need to check those. Anyone used Redis cache in Azure? Okay. How? Okay. Okay. Sorry. Okay. So you can say the question again, and I repeat it in front of the camera. Anyone use the cache, Redis cache service, Azure cache?
So it's like we can use the SDKs online.
So in my project, I have used this Redis cache mainly in kind of, there were so many backend tables and there were so many records that needs to be fetched. So we used to have this Redis as an SDK, and we will be using their methods for caching. And it was kind of 4 years before I have used that. And at that time, we used to have that portal, Redis portal, and we'll have a Redis cache key. And we'll be writing that, and also we will be using that cache invalidate function whenever we need to change something. We will be using that. That way only I have used.
Do you preload the cache before you start, or because it has a different structure from the tables?
Yeah.
In the cache, yeah, that's fine. But
so it's like when we have any hit.
Okay, so
yeah, if we have any hit,
cache
first
aside.
we will be going to the back to fetch, and we will be storing it in Redis.
Okay, great.
And it will be kind of there'll be a time period where if we are not using that, then it will be kind of removed. Otherwise, it will be kind of extending based on the hits that we have.
So you're actually using cache aside pattern, lazy load. So the first round trip goes to the persistent layer.
Yeah, that's true.
Getting the data, remodeling the data for the
correct. If there is any update, we will be updating that in Redis as well as in the backend, so that we'll have in the both places, and it will remain in the cache itself.
Okay.
Yeah, I never bothered about the pattern. It's kind of
but it's cool cache.
Yeah.
Do you use the fully managed service, or?
I think they have bought, I guess, that time. I'm not sure.
Not sure. Okay.
Redis cache. They have, I think it was. At that time, we were not having that integration in or not having that service inside Azure portal, I think.
Okay.
We were having using that directly, I guess.
Okay.
So it was long before. In that we were having that managed Azure Management Studio that time. So later only we had this portal.azure.com, right? So initially we used to have that Azure Management Studio, and at that time only we were using this, and there were only less services offered by Azure that time.
Okay.
But this was kind of a, I have just used it, but integration has been done by some other developers, so
Okay.
I was using this for things.
Convenient.
Yeah.
Yep. Those are the Azure use. It's a distributed application caching. Redis. Everyone talks about Redis or Memcached. Those two. Azure only Redis. I think the support for Redis only. If you not put up in the container and use that way, you can use Memcached. Azure Cache is, I believe, Redis support only. But it's fine. It's the better one. It's a bigger one, a larger, I would say. Yeah. AWS got Elasticache, Redis or Memcached, or Google Cloud Memory Store, it's called, Redis or Memcached. Doesn't matter. These are fully managed services. In this case, not meaning linear auto-scaling. Not that, but it's fully managed. They offer like clustered versions of the cache. I think it's tiers. Using cache, you can use it as you say, as your cache side. You can use it as an inline cache, meaning the other system record. You set up rules for the cache to actually flush to the persistent layer. And then it becomes the system record, the primary source. Then you need to cluster it. You must cluster it, otherwise you might drop data. So in this case, doesn't really matter. You can actually, it gets slower, but it works. But if you use it as an inline cache, you need to cluster it. And I think even the lowest level of the Azure, I got 3 tiers. I think that is 2 instances of the Redis, primary and backup. However, it's the most convenient way to use the Redis cache in Azure or any other cloud vendors. Way to do it. You can also fine-tune the offers, exactly how to set up the cluster and so on. And the offers already in REST API. You can start, create, get, set, invalidate keys, and so on in that cache, fully managed service, which is good, which is nice. However, what I asked you before was actually this. I've seen this a lot. You can set up using containers and set up an ambassador pattern. Again, sorry for the patterns. Set the Redis instances in ambassadors, fronting the main application. That's a common use for doing things. That's what I was asking. Is it fully managed services or using the orchestration service, container orchestration service? Open up ports for exactly those what you need to support. This is an exercise in our architect program. we do it this way. That's what I'm asking. But it wasn't your problem. Here it is, here how you connected and so on. But either use the fully managed services, cache services, or set it up your instances in the ambassador pattern way of doing things in containers and use the container orchestration services in Azure, for example. The thing is, why I'm asking it, either you have an infrastructure team, let's say, I don't know what they call it, or when you set up a cloud solution, what comes with that? It also comes different from before. You need to set up a total cost of ownership. Okay, how much does this cost, monthly cost, this design? Let's say you have a scenario, so many transactions and so on. What's the cost, monthly cost on that solution to compare to the other? Have you done that? I hadn't had to do it, so I guess you need to have to do it as well. So everything is pretty easy to you have these calculators as well. the cloud calculators. Every cloud vendor has that. You set up, this is the monthly cost for the company. So if you're a consultant, okay, what's the price for it? And you probably need to set up 2 different system designs. So here, we can do it this way for that cost. It's like could be a third of the cost of using fully managed services. I had this before the Kinesis, the streaming services of the AWS. It's so expensive, so so many tries to avoid that. So, for example, and I guess some of the fully managed services has the same problem, but there's a convenience. So you need to compare those things when setting up a solution. But here's the common thing. So you cache, we do it this way, and use one of the patterns, either cache aside or inline cache. Further down, let's go down to the basement. What can you do here? Someone used the ORM caches, like the first ORM. What's that? Pardon me? Yeah, Entity Framework is one, especially Hibernate or Entity Framework is those 2 biggest ones. You have objects on the back end, and you got relational database. You need some sort of mapping between them. Here's an object, and here's a row in a database. Quite, at least it was widely used. I'm not sure now. But you can cache there as well. The end cache for Entity Framework. Hibernate, different name. A bit different thing. They first went to the current session of objects that are instantiated. First, that's the first level of cache. If not, they use the cache aside parent. Okay, we need to go down to the persistence layer, instantiate the objects, put on some sort of cache aside. Other things you can do to speed things up. We could comment cache. This is not a cache, is it? It's a technique. If we're using relational databases, a common technique is to create physical read-only database copies, mirrored databases, called read replicas, or add database snapshots. Not the same thing as table snapshots, okay? Database snapshots. Using these mirrored copies, then you need set up an update pattern for those. How do you update it? How often, and so on, in order to reflect the current data. More we can do. Any suggestions on a relational database? I saw the SQL Server service had these options, how to set read replicas, update patterns for all that, and sharding. Yeah, that can be used as well. And the services guides you through how to do it. I think it's more of technique as well. You got physical databases, same exact definition of the tables and so on. You put the first row in one, in this case, user table, one database, second row, another database, and the third is another. For the client using it, the backend, it's in they don't know of the 3 databases, just know of one. So it actually looks as if it is one database for them. So from the outside, it's still regarded as one database. Sharding. From the relational databases to the NoSQL database, document databases, and so on. So let's say we're not using the SQL. Someone used this one, Cosmos DB, I guess, probably all of you. They added a cache on top of the database. Here's AWS, by far the biggest persistent database of their service, DynamoDB. They added the caching service, DAX, on top of that. Can be clustered and so on. Now, since last autumn, Cosmos DB did the same. using. So you don't not need the Redis cache. You can have a Redis cache in front, as you did. But they have this integrated cache as well. It's quite new. Same thing. In this case, as you see, we're not using the cache site pattern here, as you were in. The application doesn't know the DynamoDB. So we'll know the cache, because the inline cache. And we, in order to use that, we need to have some read-write strategies for that service. Doesn't matter if it's Cosmos DB or DAX. So all in all, as we can see, we can cache almost everywhere in our internet-based solution. So you need to start up here, client-side caching, apply those patterns, cache-side patterns for the local cache in order to, or if you have PWA requirements on your app, that's one way to go. DNS lookups. Now, Cloud DNS Services offers you more add-ons. You got the weighted routing and so failovers and so on. All at that level, DNS level, especially used in multi-regional systems. And even caching your virtual network names and so on. And then we move to the static CDNs, CloudFront, it's called in AWS, edge caching, static web content. Using the CDN edge pop edges, no, same thing. With a proper system design, you can really use an accelerator system. So static web content can be used, the whole infrastructure with the regional cache that cloud vendors offers, and to the closest edge locator nearest the user. And then got response cache, the gateway. If you're using Azure API management and so on, doesn't matter. The response cache that caches the responses, and in a Microsoft microservice architecture, this can really speed things up. You don't need to go. You need to go to all your resources, sources, and aggregate the response. You can cache your aggregated response and then return it to the client. And next time with the cache hit, it go much faster. So here's one thing to actually go for caching. And then we come to the Redis cache. Azure cache, it was called. You can implement it with Redis. We can use the Redis cache in Azure already here in the API gateway, as we saw, which is a very nice feature. But after that, we go through the portal to the system. You can use the cache, the distributed cache, as you said, using that as a cache aside in your case, or an inline cache. We come to those patterns again. And then go to the databases. If you use your relational database, we got the techniques model. I call them techniques. We got the ORM layer first, caching, entity framework, and cache, hibernate cache, same thing. And then go to the techniques of the relational database with the sharding, read replicas, and so on. Try to see the configuration in your services, like the SQL Server service in Azure. When using these Redis and Memcache, you can either try the fully managed service, could be more expensive, more convenient. Especially if you go to the premium levels, usually quite, it doesn't matter in the cloud, it's pretty expensive. Or a common thing to do is install the cache instances in containers and use the container orchestration services in your solution, AKS, let's call it Azure AKS, for example. So where you cache, so go home, Michael, to your systems, where do we cache? How does it affect the other cache as well? So I need to say, now I've been talking about caching patterns, and I need to address them. And actually saying how to cache. your response there, how do you cache? How do you use it? And there are some Paris is a common language where you discuss designs, system designs. How many have used it? No one? Okay. Well, that's for that language. But how do we cache? There are actually two main cache patterns that are commonly used and applied. And there are more or less two more major caching products as well, as you mentioned, Redis and Memcached, sorry. We start with the patterns. Doesn't matter if it's Redis or Memcached. Cache aside, which you had in your previous project, and the inline cache. First about the responsibilities. Here's in the green, you have your app, your system. Your system in the cache side, lazy load, knows of the cache and knows of the database, both. And it's responsible for the synchronization of the cache and the database. However, in the other pattern, inline cache, as I said, your system only sees the cache. And I got this one, I come to back later, but in general, it only sees the cache. It only knows of the cache.
It is always cache in front. Is that the inline cache? So
Yeah.
like we need to make sure that both the cache and the database have same data all the time.
If you are responsible for that, you know both of the cache, then it's up here. You are here. You know the database and you know the cache aside pattern. If you don't, if you just know the cache, it's in front. You don't know the persistent layer at all. You don't know which database and so on. It's not your problem. Fine.
How is that getting updated in the backend?
Yeah, I will come to that. Exactly. But that's the good question. You need some sort of rules for for the cache to actually know how to deal with the backend. That's main. It's a good question and good reflection. But first of all, okay, the responsibilities for your part is here. You have both the responsibility in order to synchronize both the cache and that's your responsibility. And the other hand, in inline cache, again, you only see the cache.
That seems to be less overload. But I don't know how cache is going to work.
Yeah? We start with the cache aside, the first one to the left. There are some scenarios we need to go with the cache miss. Here's the request. Look in the cache first, doesn't exist. Need to go to that loop for the request to the data store. On the way back, as you did, put it in the cache. Maybe some remodeling. That's one. How do you say? Good things we can do with the cache aside. In the inline cache, you can't. They need to be on par with the persistent layer. In this case, it's up to you to actually set. You can set another structure as a key and the structure for that, which is good. So cache aside, but you are the responsibility for synchronizing the cache, and you set a TTL to something, probably. That's a good pattern, good common thing to do. Some advantages of this pattern. Okay, before we return it to the client. Only used data is cached, right? Nothing else. And failure of the cache nodes are not fatal for the application. You can actually usually go there and return. It might work, but slower, but it will work. Some disadvantages, though. Can you see some? Well, some talks about the cache miss overhead. Well, if you're not using a cache, there is an overhead for the cache miss. look for data in the cache. That's one overhead. If you got nothing, and so on. If it's not there, you get to request the data, and you update the cache, or setting the TTL, and so on. So they talk about.
We need to make sure that we know at what time we need to remove those things. Like if we have a scattered project somewhere and forgot to validate that cache, then that will be a chaotic situation.
Exactly.
Yeah.
We'll come to that later. Next scenario is cache hit. First cache miss. Cache hit. Here's why we cache in the first place. We speed things up. It's not that hard. You need to reset the TTL expiry date, probably. It's another 15 minutes or 5 minutes or 10 seconds or whatever. And here's what you are now into, updating, invalidating. So here comes an update. You update the data store. Someone updated. Could be from another place or other part of the system or so. It's updated. You need to invalidate the cache somehow. Redis, if you are allowed to have those structures, it can be quite tricky. As you were into that. I was involved in the modification of the cinema theater. We had the cached booking seats, and some parts of the cinema theater was modified. You needed to invalidate all those seats, for example. There was some discussion of that. So it could be more complicated than you think, but you need to invalidate the cached values as well. Otherwise, you get some stale data. Or at least you need to ask what modifications will imply invalidation of the cache. Let's move to the other pattern, the inline cache. Cache SOR, system of record, or cache as SOR. The application only knows of the cache and not of the underlying database, hence the name, system of record. That means the cache itself is responsible for synchronization. And I had this one, but I'll come to that. Then you need to tell the cache how to synchronize, how to do that, what they call the read-write strategies. So inline cache needs some read-write strategies. And you can combine them. So what about reads, what about writes, and so on. First we start with the read-through. You always read from the cache instead of the cache side. Go to the cache. The cache doesn't recognize this key. Needs to go to the database, set up in the cache, and then return it. So always two reads in this case. Next time, it will find in the cache. So it's called a read-through write strategy. The strategy is called read-through. Next time, combine with write-through. Application writes to the cache. You set up the configuration of the cache as a write-through. Each time writing on the cache, it writes to the database. The overhead is, okay, you got always two writes in one single transaction. So that's the overhead and this. Could be some extra latency having this, but you're free from the invalidation of the cache. It always reflects the same data. But there are some latencies. Therefore, you have this write delay, write back. Sometimes called write back, where the application uses the updates the cache, but in some asynchronously updated the persistence layer. Could be pub/sub pattern, or I think timed threshold flushes to the persistence layer. So depending on the vendor or service. Some of the biggest very transaction-intensive applications in trading, the whole product looks like this. You can't persist everything, but you need to cluster it. You need to cluster this cache. and it flushes the transactions timely, asynchronously, either by a pub sub or timed thresholds. Thresholds flushes. But in this case, clustering the cache instance is a must. Okay, this guy here, right behind or around, and I saw the DAX, the AWS DAX cache used it, and there are some other services as well that use it. So, in this case, you write to the database, as you would do in the cache aside pattern. You write. You don't need to invalidate the cache. It fixes. They know each other, so it actually reflects that updated as soon as you update the persistence layer. It's called the write behind, write around. These caches, the inline caches, are very much used in the NoSQL databases. So don't usually have cache aside patterns using relational databases because you are able to change the structure. And you probably need to change it. There are 5 tables, you can't do that. And here's the object, or put a key on it, and here's the cache. So, so that's why.
It's not a battery. I think it's not a battery. I'm sorry.
Yeah, it's okay. Did you have a question?
No.
Okay.
It's the sound in the headphone.
Oh, okay. Now we come to the part talking about stale. The data, you need to validate that. The data in the cache could be stale or stale state. So why don't we just cache everywhere? Is it mine? Not sure. As a proper party pooper, I need to tell you there are some drawbacks. Otherwise you could cache everywhere. The system is broken. The data in the cache has gone stale. Which data? Yeah, well, some data along the line. What it means in short, it doesn't reflect the actual data anymore, the current data. That's what it is. And you need to address the risk of consequences. Let's say you have a validation or assumption based upon stale data. It could be disastrous. You can make a decision on false premises. So how do we? And here's the reason why many see caching as an anti-pattern. So many sees not caching as an anti-pattern, and many sees caching as an anti-pattern. This is the reason for that. How do we address this? First of all, we know in the cache data regarding, when the cache updated data with the persistence layer not reflected in cached value, in cached data. That's the reason. How do we address those? How can we address them? You can actually work active, you mentioned it, or passive. Passive, I'm not sure, but that's that good word, not sure. Or both, pro tip. Use both. So, as you said, if you are the cache side, you're responsible. You know of the database. You know of the cache. It's your responsibility to synchronize those. So, if an update's occurred in the database, you need to invalidate the key in the cache. Right. So you can do it with code. That's the active approach. Or you could, but as I mentioned, the cinema theory. Okay, if some related data is modified, is that affecting the cached values? Could be as well. It's not just straight table to. You had a different structure as well in the cache. So you need to be aware of that. But here's the active approach, which is a good one. As soon as you update the source, make sure it's reflected in the cache, invalidate the cache. Next time it will be used, you need to go the whole loop again, the cache miss loop, but that's the cost you need to take. So the whole cache miss round trip needs to be used next time. The passive approach, I know it's slightly off to call it passive. You use TTL. TTLs. It stands for, I don't like it, it's not an expiration date, it's more like a timer. You set it, usually sets in, stated in seconds. So when reach, the related cache data will be invalidated by the cacher product itself. Use both. When you know this update is actually affecting this cached key, fine, invalidate the key. And don't have too long TTLs. Sometimes it could be stale. And could be some weird consequences. So use both, that's the tip. Okay, caching products. As again, talking distributed cache, I heard Redis. And here's one thing, the best thing that you already mentioned. You can have quite complex structures, bigger structures. Memcache is a simple key value store. That's the difference. Azure Cache doesn't support, I'm not sure, it doesn't support Memcache. Not sure, I don't think so. But they support Redis. If you like to use it as a key value store, fine, up to you. So this one, but you know, we need to use Memcache. Well, one good thing, or if you got a relational database, you can use to modify the structure and use it. Put a key to it and have the structures cached. You can actually use it in the database. You can have backup and restore for that. So the whole caching could be as Redis cache could be actually used as a database. Memcache not. As you see, there are quite small objects as well in Memcache. Here are some big players using them. Now I think it's more like everyone uses everything, more or less, depending on the needs in that scenario. A quick reference back to the cloud. Of course, the cloud vendors offers fully managed services for caching, as we saw. And again, you can always install Redis or Memcached in a container and use the services, Azure Container Service, for example, for the orchestration of those containers, and use the ambassador pattern for that. So anti-patterns, pitfalls. Anti-patterns are everywhere. Caching is no exception to that. Sure. Anyway. Again, many sees caching as an anti-pattern itself, and many sees not the cache an anti-pattern. Caching keys without TTLs could be stayed forever. That's what you need, always. Keep them pretty short. Okay? When updating, you know this data is exactly mapped to this structure in the cache. Invalidate the key as well when updating. If you use the cache side panel, it's your responsibility to synchronize those, okay? Caching everything and everywhere without control. Let's say you use caching everywhere. We got the local cache, we got the DNS caching, we got the CDN caching, web context, we got the response caching, the API level, and then we got the distributed cache of the Redis, using some sort of pattern inline or cache side. And the database as well, some techniques for that. We can go for assumptions and validations could go wrong. Those are based on stale data. So, you can re-caching. This cache is cached on caching. Cached values and so on can be like a flow of cached values, and suddenly you don't know what it is. So that's caching everything and everywhere without control. So I would like you to test those other services, cloud services, test the CDNs, for example, for static web content, use caching on the API management, Azure main, and so on. But remember where, the whole team must know where you cache and use those patterns for it. Caching too early, I'm not meaning the system-wise, I mean project-wise. Oh, we need to cache. Oh, based on the solution is based on caching. If you got transaction-intensive system, you might look at like gigaspaces and so on that looks like an inline cache. That's the primary source of data and flushes out to other persistent databases. But caching too early, start with your system. You might have the static web content. Okay, we might put it in there. That could be early decision as well. So those decisions of caching, don't start with that, at least. It's caching too early. Caching of startup. Usually, that's when do you cache? Now lazy load you have, you got the cache aside, which is fine. Only caching data, sorry. Sorry, I went. So let's summarize. Got the why. What do you cache? Speed things up. Now we got the where. Where do you cache? You can from the client all the way to your core system using distributed cache, fully managed service or containerized instances of your Redis or Memcache, and the database techniques for that, and the response caching here. And Azure has this response connection with the Redis cache as well. Pretty neat to set it up easy. So you get the response caches there. And CDNs for static web contents. So all those places might come up in your solution, especially on the cloud solutions. The how, we got common cache patterns. Which have we got? Which ones? Cache aside, lazy load. We got the inline cache system of record. And it's easier when you think of responsibilities. What's your responsibility as your application? Do you know both of them? Do you know one of them? If you know one of them only, you need to set up rules for that one to handling the synchronization. That's the read-write strategies. How to handle stale state, use short TTLs, invalidate cache when updating, and so on, if you're responsible for that. And having back in mind the anti-patterns for that pitfalls. It's a classical quote on this. You've probably seen it before from Phil Carter, University of California. There are only two hard things in computer science: cache invalidation, naming things. Not sure. Okay, thanks. Well, yes, as you saw, I'm more of a cloud agnosticer, I would say that. However, my closest and nearest colleague is our Azure expert. So if you have any questions on how to configure, what to choose, I'll be glad to help pass you that question if I can't answer it. So more than glad to do it. So, or configure the Azure Cast, for example. Here we are. Here we are presented in Lund. You can go to this site to find out more about us. And thanks for listening. Okay.
Thank you. That was great. Caching is essential for any effective system, I would say. Where's the... And It was a nice overview. Good that you showed that it works in all clouds and all systems. So thank you. I just wanted to go through some things. Of course, I'm going to do it like this. So we already heard the presentation. We have the agenda. So you can see we already 1 minute past. The pizza should be here. It's coming, promise. Azure Skåne, this is the group. It's all about learning, networking, having fun. I learned a lot, thank you. Network, yeah, that's what we're doing now. And it's always fun to see people and be here, at least for me. Maybe I'm strange, that's another topic. So Azure Skåne, who are we? It's us four that's trying to do these events from time to time. If we look historically, we managed to do 10 plus events a year, which is pretty fun. So almost once a month. Negar, she's here today. Do you want to say what you do? Want to present yourself?
Yeah, Negar Shavos. I work as a Microsoft Cloud Solution Architect at Capgemini here in Malmö. Yeah.
And then we have Goran Vuksic. He's an AI MVP. He works at Pandora in Copenhagen as a developer manager. Magnus Mortensson, he's also an Azure MVP. He's an own contractor. So if you have issues you want to solve, you can always call him. And me, Michael, I work at Microsoft in Denmark. I was an MVP before, but you can't be that when you work at Microsoft. Yeah, everyone knows where we are. So this hashtag, please use it if you tweet, write something about us, post on LinkedIn or whatever. We are present at LinkedIn, at Twitter, at YouTube. At YouTube you can also find this presentation eventually. All our presentations are there. I think we have around 46 events there, so a lot of good content learnings that you can follow. And of course, please use the hashtag if you post something. Always grateful to Foo Café, and today also Capiche. If you want to know more about Capiche, he will join us for pizza later. This one. So I see some of the regulars, they know what to do. This is an NFT that Microsoft has produced together with Engine, a company in Holland. When you scan this code now, you can claim this badger. It will be your NFT, you can have it in your wallet. Eventually, you can collect as many of these as you want. There's different ones, community hero, content hero, inclusive leader, etc. There you will get a learner one. There are 30 of these available in this batch, and you won't be able to collect them after 4 o'clock tomorrow. So that's the window we have to collect it. It's fun to have those, and I will show a site also just to gamify it. The value for this will eventually be that you could join a conference and show how many of these you have. We can see here, for example, in Sweden, there's 300 users, 299 ones, and 543 badges has been posted since this started. The states are a little bit bigger, Russia, yeah, and Ukraine and so on. So it's a pretty good, fun thing. Some of these are rare. You can see Content Hero, very rare, 250 available, and so on. Green Contributor, 75 available. I know there's only one that has them. So, you know, and there's the criteria how you get them. So please collect the learner badge for today. Good. And now to the really cool stuff. The next event, 13th of May. We will have 2 live podcasts. Developers podcast, anyone know which one that is? No? Then I highly encourage you to listen to it. It's in Swedish. So the event will be in twofold. The first half of the day will be in Swedish. Then we will have an Azure expert session. It will be bilingual. And then the second half of the day is the second podcast, and that will be in English. And we actually have the host present today, so it will be really nice. So please join that one also. 13th of May on a Saturday. Pretty cool event. They will have 2 guests. You will have 1 guest. 2 guests. So, yeah. So full house. And somehow we will manage to fit that in here, and people will be sitting around and listening, and it will be a live podcast. Awesome. As I said, it's a very friendly environment, this meetup, so any level is welcomed. And if you feel that you have something you would want to share with us, or if you want to do a presentation, if you are thinking about getting into it and maybe feel that, yeah, I'm not comfortable enough, this is a safe place. Everyone is welcomed. Use this as your starting place, maybe, if that's what you desire, or if you just want to share something. Or anyway, we have an open call for content. You can submit it there. You can also find it if you ping any one of us organizers. Yeah, please do that. And another cool thing, Gregor said that if you have any questions, you can always reach out to him and so on. But we actually have a really nice community. I'm the only one posting stuff there, but it's nice anyway. No, we're actually getting some traction there. So it's a Discord server. We started this one during the pandemic. The reason why we started it was that, you know, we did a lot of online sessions, and it didn't feel that we had this conversation. So this Discord is active, and one thing that I've noticed is people, when they join, they miss this one. Please checkmark this. It's just, you know, some small rules that you read it, you agree not to be a person that mentions dumb stuff. Just a small note, for example, Azure updates. I use this daily in my own work. If I come across any cool stuff, I put it here, because then I know where it is when I want to find it. It's a really easy search function. And I also use this one because I need to stay updated on all the new stuff that comes in Azure. And this one automatically pushes out all the new information. So it's an easy way for me to stay updated. And if I have any questions, I try to use any of these groups here. I post a question, start a discussion somehow. So yeah, I'm just doing a lot of advertisement here, but it's a really good place. And if you have any caching questions, join this one and ask away. Personally, I try to help with everything, even if I don't know it. I try to look it up. I can always check something internally at Microsoft if that's the product you're looking for, and so on. That was it. Let's eat.